Hi guys, so today we're going to be talking about arithmetic series. So before we get started, let's talk about what a series is. Okay. So a series is an indicated sum of the terms of a sequence, right? So if you had a sequence 18, 22, 26, 30, and 96, 18, 22, 26, and 30, right? If that was your sequence, if you added each of these terms up, that would be a series. Okay. So for example, 18, 22, 26, 30, that's an arithmetic sequence, and then when you add them, 18 plus 22 plus 26 plus 30, that then is known as an arithmetic series. Okay. So arithmetic series is just the series for an arithmetic sequence. Okay. And we denote that with S sub n, S for sum or series, and then n is how many terms you're adding up in that series. Okay. So for example, S sub 4 is the sum of the first 4 terms. Okay. Here, to develop the formula for the sum of an arithmetic series, if you look at the series below, there's 9 terms, 4, 11, 18, 25, 32, 39, 46, 53, 60. They're being all added up. Okay. When you write it in 2 different order and add the equations, it all ends up being 64. But then now there's 2 of them, right? Okay. And then if you it's 9 terms times 64, and then if we divide by 2, because this is 2 of that same series, that's 9 half times 64, right? So 64 comes from the changing of the order and then adding them, okay? And 9 comes from, since that happens 9 times, but the sum had 9 terms. Okay. And then 2, because you added that series twice, it's just the second time it was in a different order. Okay. So as a result, the formula for it is here. It stands for n, how many terms there are, right? So in this case, there were 9 terms divided by 2, and then it's the first one plus, right, in this case, the first one was 4, plus the last one, the 60. Okay. So that formula is here, right? And then another way you could write it is like this, and really it just changes the a sub n with what we know about an arithmetic sequence was anyways, right? A sub n is a sub 1 plus d times n minus 1, and so if we have a sub 1 from here plus this, that's why it's 2a sub 1. So really these are both the same thing. Let's get started with our first one. Okay. So here we want to find the sum of the first 100 positive integers. So what we're talking about for the first positive integers is 1, 2, 3, etc. Okay. So our formula is S sub n equals n divided by 2, a sub 1 plus a sub n. Okay. Or you can use the other formula where it just rewrites a sub n with the formula here. So because a sub n is a sub 1 plus d times n minus 1, the a sub 1 and this a sub 1 becomes 2 a sub 1s plus d times n minus 1, and you'll see that we get the same thing. Okay. So here we want the first 100 positive even integers, so that means it's 100 terms, right? So that's 100 divided by 2. The first term then is 1, and then if it goes 2, 3, 4, 5, the last one would be 100. Right? 100 divided by 2 is 50. 1 plus 100 is 101. And then 50 times 101 is 5050. And you'll see that if we use this formula, right, this formula comes from this a sub n, you'll get the same thing, right? So S sub 100, because it's the first 100 positive integers. So 100 divided by 2. 2 times the first term, which is 1. Plus our common difference, so in each term, we're adding one more, right? 1, 2, 3, 4, 5. Adding 1. We have 100 minus 1. 100 divided by 2 is 50. 2 times 1 is 2. 1 times 100 minus 1 is 99. And we get 2 plus 99 is 101. And again, 50 times 101 is 5050. Either way, we get the same thing. Right? So depending on what you're given, right, that might change which one you want to choose. But either way, they'll get us the same thing. Okay? So why don't you try CYP1, and then once you're done, come check your answer. Okay, you should have gotten 2550. If you got that right, you can move on to example 2. If not, here is your explanation. Okay, so here we want the sum of the first 50 positive even integers, so that's why it's sum of the 50 terms. Okay, so equals 50 terms, the n, divided by 2. Okay. And then this time I chose to use this one so that way I wouldn't have to figure out what the last one was. Okay, so then it's 2 times our first term, so positive even integers, that's 2, 4, 6, 8, 10. Okay, so 2 of our first term, so our first term here is also 2. Plus the d common difference here is plus 2 more, plus 2 more, plus 2 more, so that's why 2 here. And then since 50, that's n, 50 minus 1. Okay. So 2 times 2 is 4. 50 minus 1 is 49, times 2 gives me the 98. 4 plus 98 is 102, and 25 times 102 is 2,550. Okay, so next one here, we're looking for the first term. Okay. So a radio station is giving away a total of $124,000. Okay. In August, if they increase the amount given away each day by $100, how much should they give away the first day? Okay. So let's get started. Okay. So here, this is a sum, right? It's the total. So each day added up together by the end of August, it will be 124,000. So this tells me this is a sum. Okay. Then again, it's n divided by 2. Okay. And then this time, since I don't know off the top of my head what the last term will be, I'm going to use the formula where it uses 2 of the first term plus my common difference times n minus 1. Okay. And I'm going to plug in what I know. Okay, so the sum in the end, okay, I know is 124,000, so I'm going to plug that in for S sub n, because that's what it all totals up to be, or adds up to be, 124,000. Okay. In August, there's 31 days, so I'm going to plug in 31 for n. Okay. So August has 31 days. Okay, so that's why it's 31 days added together. So that's why I'm going to plug in 31 here, and I'll eventually plug it in here as well. Okay, 2 times my first term. Okay, so I don't know what that is, right? That's what I'm finding, right? How much should they give away the first day? That's what I'm looking for. So I don't know what that is, so I'm just going to leave that as my variable. So 2a sub 1. Okay. However, I know that they're increasing by $100 each day, so that's the common difference from day to day. So that's going to be 100 increase by $100 each day. So that's why it's going to be positive 100, and then again 31 days minus 1. Okay, and then now the rest of it is really kind of similar to algebra 1. Okay. So to get rid of the 31 divided by 2, right, it's times 31, right, dividing by 2, so I'm going to do the opposite. I'm just going to put it on this side because there's not enough space. So the opposite of divide by 2 is timesing 2. The opposite of timesing 31 is divide by 31. So what I do to one side, I'm going to do to the other. Okay. Then 124,000 times 2 divided by 31 is 8,000. So this becomes 8,000 equals, this cancels, leaving me with 2a sub 1 plus 100, and then I'm just going to do this in one go. 31 times 1 is 30. Right. Just going to keep simplifying it here. 100 times 30 is 3,000. I'm going to subtract the 3,000 on both sides. And this gives me 5,000 equals 2 times the first term. So let me just rewrite it up here. So 5,000 equals 2 times the first term. Okay, so since this is 2 times that, I'm going to get rid of it by doing the opposite of times, which is divide. And then 5,000 divided by 2 is 2,500 equals a sub 1. So how much should they give away the first day? They should give away 2,500 the first day. And there you go. Okay, so why don't you try CYP2, and then once you're done, come check your answer. Okay, you should have gotten that Aiden did 20 push-ups on March 1st. If you got that right, you can move on to example 3. If not, here is your explanation. Okay. So here we know he did a total of 1,085 for the whole month, so that's the sum, and so that's why 1,085 replaces S sub n. Okay. So it was the month of March. March has 31 days, so you're adding up push-ups for 31 days, and so that's why that's your n here. We know that he increased the number of push-ups each day by 1, so that's the common difference, so that's plugged in for D. And then the question asks us, how many push-ups did he do on March 1st? And since that's the first day, that would be a sub 1. Then you're just slowly going to solve for a sub 1. So to get rid of the times 31 divided by 2, I do the opposite. So opposite of divide by 2 is times 2. Opposite of times 31 is divide by 31. Do it to both sides to balance it out. Okay, and that gives me this. Okay. Here I simplified 31 minus 1 is 30. 30 times 1 is 30, so that's why it's 30 here. Then to get rid of the plus 30, I do the opposite, which is subtracting 30 on both sides. That gives me 40 equals 2 times a sub 1. Since this is multiplication, I get rid of it by dividing. Okay? And then 40 divided by 2 is 20. And so since a sub 1 stands for how many he did on the first day, Aiden did 20 push-ups on the first day. Okay, then we're on to example 3. Okay? So here it asks us to find the first 3 terms of an arithmetic series in which a sub 1 equals 9. So first term is 9. A sub n, in this case our last term, is 105. And the sum of all these terms from 9 to 105 is 741. Okay. So here I'm going to use this formula where the sum is the number of terms divided by 2, times the first term plus the last term. Okay, so here I know the sum of all of the terms is 741, so I'm going to plug it in. Okay. I don't know how many terms there are from 9 to 105, right? There's no number here. So I'm going to leave it as n. Okay. A sub 1 is my first term plus my last term, a sub n, is 105, right? So what this is doing is that this is helping us find how many terms we're adding up together. Okay. So I'm just going to simplify that 9 plus 105 here. 9 plus 105 is 114. 114 divided by 2 is 57, so this becomes 57n. And then I'm going to divide by 57 on both sides. And 741 divided by 57 is 13. Okay? And so what this does is here, my first step is to find out how many terms were added. So there are 13 terms. 13 terms that were added together. Okay. Then, using that, I can figure out what the common difference is. So using this formula, a sub n equals first term plus common difference times n minus 1, I now know that this is the 13th term. Okay, so 105, right, because a sub n stands for any term, so one of the terms is 105, equals the first term, which is 9, plus whatever the common difference is times the place in line it is. So again, this is the 13th one, minus 1. Okay. So 13 minus 1 is 12, so this is 12d. I'm going to subtract 9 on both sides, and that gives me 96 equals 12d. Divide by 12 on both sides, and that means 8 equals d. Okay. So to find the first three terms, I know the first term is 9. Okay. Then, if the common difference here is 8, I'm going to add 8 to get the next one, and I'm going to add 8 again to get the next one after that. So 9 plus 8 is 17, and 17 plus 8 is 25, and so here are now my first three terms. Okay. So why don't you try CYP3, and then once you're done, come check the answer. Okay, you should have gotten negative 16 as your first term, negative 9 as your second term, and negative 2 for the third term. If you got that right, you can move on to our last example. If not, here is your explanation. Okay. So here we know the first term is negative 16. The last term in our sequence is 33. We don't know which place it is in line, but we know that the last term is 33, and the sum of all of the terms from negative 16 to 33 is 68. Okay? So using our sum formula for an arithmetic series, 68 equals, again, we don't know how many terms there are, so n divided by 2, and then our first term, negative 16, plus our last term, 33. Okay. Negative 16 plus 33 is 17. Just because there wasn't an easy way to simplify that 17 over 2, so I just got rid of the divide by 2 by timesing 2 on both sides, and got rid of the times 17 by dividing by 17 on both sides. So essentially it's times 2 divided by 17. So 68 times 2 and then divided by 17 is 8. Okay, so that means there are 8 terms in my sequence. Okay. So then, to figure out how far each of them are apart from each other, I need to find the common difference. So using my arithmetic sequence formula, I plugged in any term, right, a sub n. So 33 equals my first term, negative 16, plus my common difference. I don't know what that difference is, so I leave it as d. And now that I know that 33 is the 8th term, that's what n stands for, it's 8 minus 1. That gives me 7d here. Got rid of the minus 16 by adding 16 on both sides. That gave me 49 equals 7d. Got rid of the times 7 by dividing by 7 on both sides, so d equals 7. So here, first term is negative 16. Adding 7 to get my next term, which is negative 9. Adding 7 to get my next term, which is negative 2. Okay. Okay, so our next example has to do with something called sigma notation. Okay, this letter here is the Greek letter for sigma. Okay. And so instead of writing out a whole series, right, such as 3 plus 6 plus 9 plus 12 plus blah, 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 plus 30, there's a more concise way to write it known as sigma notation. Okay. So for example, with this series here, we can express it as sigma notation here. N equals 1, first term till the 10th term. And how we get each term is it's 3 times whichever place it is, right? So that's why the first term is 3 times 1, Next term is 3 times 2, then 3 times 3, 3 times 4, all the way until our 10th term, which is 3 times 10, which is 30. Okay. It's read as the sum of 3n, as n goes from 1 to 10. Okay. This talks about the first value of n that we want to consider. This is the last value of n that we want to consider. And this is the formula for each term in this series. Okay. The variable, in this case it's known as n, is known as the index of summation. Okay. So again, it doesn't have to start at the first one and end at the other one. Okay. It could be something like this. And even the same series can be represented in different ways, right? So you can talk about it being from the 4th term to the 9th term and this being your formula. Or you can talk about it from the 2nd to the 7th term with this being your formula. Or you can talk about it from the 0th term to the 5th term with this formula. Okay? So different ways of representing the same series. Okay. So let's evaluate this. Okay. So here what we want is we want the 5th term, we want the sum of 3j minus 4 as j goes from 5 to 8. Okay? So what we do, 8, j equals 5, 3j minus 4 equals, so we're going to start with the 5th term. Okay, so 3 times 5 and then minus 4. Okay, so that's the 5th term, plus 3 times the 6th minus 4, 6th place, plus 3 times the 7th minus 4, plus 3 times the 8th minus 4. Right? Goes from 5th to 8th, right? 5, 6, 7, 8. So here, all I did is I took trace from 5 to 8 and plugged it in here. So 5, 6, 7, and 8, and now I just simplify. Right? So 3 times 5 is 15, 15 minus 4 is 11. 3 times 6 is 18, 18 minus 4 is 14. 3 times 7 is 21, 21 minus 4 is 17. 3 times 8 is 24, 24 minus 4 is 20. Note that here the difference is 3, right? 11, 14, 17, 20, that's where this 3 comes from. Okay, and then I just need to add them all up. 11 plus 14 plus 17 plus 20 gives me 62, and so that is its sum. Okay. So why don't you try CYP4, and then once you're done, come check your answer. Okay, you should have gotten 45. If you got that right, you could get started on your homework. If not, here is your explanation. Okay. So here I want the sum of 2k plus 1 from k, where k goes from 2 to 6. Okay. So here, using 2k plus 1, I'm going from k equals 2 all the way to 6, right? So that's why it's 2, 3, 4, 5, 6. 2 times 2 is 4, plus 1 is 5. 2 times 3 is 6, plus 1 is 7. 2 times 4 is 8, plus 1 is 9. 2 times 5 is 10, plus 1 is 11. And 2 times 6 is 12, plus 1 is 13. Okay. Note how 5, 7, 9, 11, 13, it's a difference of 2. That's why here it's 2k. Okay. Add them all up, 5, 7, 9, 11, 13, and the total will be 45. And there you go. So that's it for today. Have a great rest of the day. Bye, guys.